Good morning and welcome to this educational video on the topic of mutual inductance. So mutual inductance is the crux of the working of transformers, motors and generators. तो जो म्यूचुअल इंडक्टेंस होती है उसी के बेस पे ट्रांसफार्मर, मोटर और जनरेटर चलते हैं. तो आज हम समझेंगे कि म्यूचुअल इंडक्टेंस होती क्या है. Let me just explain you what mutual inductance is. So generally you're able to appreciate the concept of mutual inductance only when you get into the topic of alternating current, because in the case of alternating current you have time varying current available to you. Okay, but let's say you're still on the chapter of electromagnetic induction and you don't understand too much of alternating currents. We can still learn about mutual inductance. So let's say, what is mutual inductance? So if you have a coil, this coil, and you apply a time varying current to this. So this sign, this particular sign represents alternating current, which is essentially a time varying current. But forget it for a while. For you, what it means is that this is a current that has time variation, and therefore, we can write it like this. Now this coil is called as an inductor. It's a circuit that you see. Now what you do in a lot of instruments such as motor, generators and transformer is you have another coil, which comes into picture, and it could be different number of turns. Now, the current change which is happening here, so you have a time varying current in this circuit, and then you have another circuit maybe, and you have some, we can say this is some resistive load, which is connected to the second coil, and the circuit of the second coil is called as the secondary circuit. Okay, and the first circuit is called as the primary circuit. Okay, now here is a deal which you need to understand, and which is that if you have a time varying current which is flowing in this, it will produce a variable magnetic field, so a magnetic field gets generated here, so which is also time varying. So what you get, from the circuit number one is a time varying magnetic field, because every current carrying conductor has magnetic field associated with it. Okay, so what you get is time varying magnetic field, and therefore what you get is a time varying flux also, from the first circuit, called as the primary circuit. Okay, that's what you get, primary circuit. So this primary circuit is now giving you a time varying magnetic flux. Now that magnetic flux, gets linked to the secondary circuit. So the secondary circuit now receives, it receives a time varying magnetic flux from the first circuit. So the first circuit is giving a time varying magnetic flux to the second circuit, called as the secondary circuit. Now this is what is observed. When the time varying magnetic flux gets associated with the secondary circuit produces or exhibits that it has a EMF that gets generated. Okay, so what you have is a situation where the secondary circuit is having EMF and some current starts flowing in this, in this circuit. So what you're doing is you're bringing in time varying magnetic flux, which is d phi by dt, from the all right, so what you're doing is you're bringing in time varying magnetic flux from the circuit number 1, giving it to the circuit number 2, okay? And that time varying flux which gets associated with the second coil, the second circuit produces its own EMF, okay? So EMF comes in the second circuit. Now this phenomena where you have one circuit which is responsible for time varying current and then time varying current resulting in time varying flux, and that flux getting associated with a second circuit, and because of Lenz's law and Faraday's law, the second circuit also starts giving you the voltage, and this voltage then which gets produced in the second circuit is written as minus M, which is the coefficient of mutual inductance multiplied by the rate of change of current in the primary, okay, the first circuit. Okay, if you divide this, what you get is the voltage produced in the second circuit divided by the rate of change of current in the first circuit, giving you the mutual inductance. So mutual inductance is a physical parameter that connects the voltage which is induced in the secondary circuit, the second circuit, per unit rate of change of current which is happening in the first circuit. If the first circuit, the rate of change of current is very small and the voltage generated is very high, then the mutual inductance is very high, right? Because di by dt, if you decrease it, you would have so point is mutual inductance is a property that measures how much voltage can you get in the secondary circuit per unit rate of change of current in the primary circuit. This concept of having the first circuit and the second circuit time varying flux getting linked to the second circuit and the second circuit also generating its own EMF and current is called as the concept of mutual inductance, because you are exhibiting the Lenz's law and Faraday's law in a circuit which is other than the primary circuit. This is used in motors, generators, and transformers, and therefore is very, very important. There are multiple ways you can link the two circuits to get a resultant EMF per unit rate of change of current and get different values of mutual inductance for the same two coils. We will study that later, but I hope you enjoyed this video and you liked and understood the concept of mutual inductance. Thank you very much.